Hi, in this video, we're going through some questions that are similar to the questions that you'll see on the quiz you're about to take. Okay, question number 1. Below is a graphical representation, here's the graph, of a water wave, here's the water wave, created by moving a paddle back and forth in a tank. Here's the paddle, someone's moving back and forth with his hand. Part A. What is the amplitude of the wave? Remember that amplitude is the height of the wave. It's actually labeled for you right here. The height of the wave you measure from the center of the wave to the top of the wave, the crest. So right here, going from the center to the top, and then moving over to the left side, the y-axis. Okay, so the height of that wave is 0.5. 0.5, what are the units? It says right here, centimeters. Okay, centimeters. Moving on to part B, what is the wavelength? The wavelength is the distance between two waves from crest to crest or from trough to trough, bottom to bottom. I usually like to do crest to crest, top to top. So here's the wavelength. We need to figure out that distance there. Okay, so this crest is at 7 centimeters. I know it's 7 because 6 is here and 8 is here, so 7 has to be right here. And then 2 is here, 4 is here, so this crest has to be at 3 centimeters. So the wavelength is 7 centimeters minus 3 centimeters is equal to 4 centimeters. Part C. One wave pulse hits the end of the tank every 0.5 seconds. What is the period of the wave? What is the frequency of the wave? Let's start with the period of the wave. Remember, period is represented by capital T right here. Frequency is lowercase f right here. Okay, the period. Period is how much time it takes to complete one wave pulse, one wave vibration. Pulse and vibration mean the same thing. The question right here says one wave pulse hits the end of the tank every 0.5 seconds. That's your period right there. So period, capital T, is equal to 0.5 seconds. I'll just write little s for seconds. What is the frequency of the wave? Remember, there's a mathematical relationship between period and frequency. So that mathematical relationship is lowercase f is equal to 1 divided by t, the period. Do we have the period, t? Yes, we do. Do we have the frequency, lowercase f? No, that's what we want. So let's plug it in. Let's plug in t, which we have. Okay, so f is equal to 1 divided by t. T is 0.5 here. So the answer is, if you use your calculator, the answer is 2. So lowercase f frequency is 2. And what are the units for frequency? They are hertz. Capital H, lowercase z. Okay, moving on. Part D. How could the person change how he moves the paddle, physically moves the paddle, okay, to produce a wave with a lower frequency? Explain your answer. So remember that frequency is how frequent the waves are, how fast the waves are moving, okay? How many waves you have in 1 second. For example, high frequency looks like this. Lots of waves, very frequent waves. Low frequency looks like this. Not that many waves, okay? Not too many frequent waves. So if you want waves with a lower frequency, okay, then how should the guy move the paddle? He should just move the paddle slower. So just say the person could move the paddle slower. That's it. Moving on. How could the person change how they move the paddle physically to produce a wave with more energy? Okay, explain your answer. Okay, so remember, energy, there are two mathematical relationships that involve energy. So energy is proportional to the amplitude squared, which is second power, and then energy is proportional to frequency. Okay, so there are two ways you can answer this question. You can say that the person can move the paddle with a lot more force and strength to make the amplitude go up. Because if the amplitude goes up, the energy also goes up in this mathematical relationship right here. Okay, energy is directly proportional to the amplitude squared. You can also say that if the guy wants a wave with more energy, okay, the frequency can also go up, okay? So to increase the frequency, the person could move the paddle more quickly. So you can say the person could move the paddle more quickly, increasing the frequency, which increases energy. Because, and then you write the relationship, energy proportional, which is the squiggle, frequency. Okay? All right, moving on. A speaker plays a constant G note into a man's ear. So basically this is a sound wave. Okay, all right. The displacement time graph below, here's the graph, shows the movement of an air particle as the sound wave passes. Okay, I don't know why this starts with letter B. Let's ignore that. Let's pretend it's the first one, part A. Okay, what is the amplitude of the wave? Remember, amplitude is the height of the wave, okay? But this is kind of new because the wave is all the way up here. So you need to find the center of the wave, which is here, okay? And then you gotta go up to the top because that's the height of the wave. So the numbers are tiny. So it looks like the center of the wave right here is right at, I'm just gonna guess, 2.6. Okay, and then the top of the wave is at 3, so then amplitude is 3, or 3.0, same thing, minus 2.6, so then the amplitude is 0.4. What are the units? There are no units, it says arbitrary, so that means no units. So if there are no units specified, you can just write the word units, literally just the word units. Okay, moving on. What is the period of the wave? Remember, period is how much time to complete one pulse or one vibration. So here's time on the y-axis. Okay, how about we do from this crest to this crest? That's one pulse right there. Okay, one pulse. Okay, so this starts at 0.01. Oh, this over here is 0.2 or 0.02, excuse me. Okay, so then that means the middle has to be something like 0.015. I'm just going to estimate. Okay, so this could be 0.012 right there, that crest. So this crest, this crest, I'm looking for how much time it takes to complete that pulse. So then that's 0.012 minus, okay, and that crest starts at 0.01. So then the answer is 0.002, and period is always time, so that's seconds. Okay. What is the frequency of the wave? Remember, there's a mathematical relationship between period and frequency. It's this right here. Lowercase f is equal to 1 divided by t, which is period. Do you have t? Yes, you have the t, which is period. Okay, let's plug it in. Okay, so f, frequency is equal to 1 divided by t, which is the period. You have it? Yes, it's right here, 0.002. And then you can actually just leave it like that, or you can use your calculator if you want. And then the units of frequency are always hertz, capital H, lowercase z. Okay, that's the answer right there. Moving on. How could you increase the amplitude of the wave? Okay, well, here's what you need to know. So this is a sound wave, right? And amplitude is height of the wave, right? The height, which is amplitude, of a sound wave is actually how loud the sound is, the loudness. So if you want to increase the amplitude of a sound wave, you just gotta make the sound louder. So you can say, you could make the sound louder. Sound louder. Because, you gotta explain because amplitude and loudness are the same thing, same thing in a sound wave. Okay, moving on. How could you increase the frequency of the wave? So, How could you increase the frequency of the wave? Well, you can think about this mathematical relationship up here that you already used right there. So see how frequency and period are related in this mathematical relationship? They are actually inverses, F and T. Frequency and period are inverses. What does that mean? It means they're opposites because you can see here F frequency is in the top and T period is in the bottom of this fraction. So if frequency goes up, then period must go down, okay? And if period goes up, then frequency must go down because they're opposites. So something happens to one, the opposite thing happens to the other. So if you want to increase frequency, if you want to make F go up, then period has to go down. So you can say you could decrease the period because and then you can just say the mathematical relationship. F is equal to 1 divided by T. Okay, the volume of the sound is doubled. Remember, volume is the same thing as amplitude, okay, in a sound wave. What happens to the energy of the wave? Explain your answer. Remember, there are two mathematical relationships that involve energy of a wave. So energy is directly proportional to amplitude squared, or energy is directly proportional to frequency. Okay, we're not talking about frequency right now, so you can just ignore this, okay? That is not involved here. Ignore. So as you can see here, energy is proportional to amplitude squared. So if the amplitude doubles times 2, if the amplitude doubles, what happens to the energy? The energy is quadrupled times 4, okay? All right, so you would say the energy would quadruple, which means times 4, because why? Because of this relationship. You have to say this relationship if you want full credit. Energy, and then squiggle, the squiggle's proportional, energy is proportional to amplitude, don't forget the squared. Okay, and that's your answer for this question. Remember, there's no square for that frequency. Energy is directly proportional to frequency right here. There's no square there. Okay.